Hello everyone. In this video, I will explain the basic inequalities on real number system like greater than, less than, greater than or equal to, and less than or equal to, and how to add two inequalities, what will happen when an inequality is multiplied by a positive quantity or negative quantity, and whether we can multiply two inequalities, etc. These all will be discussed in this class. This class is very helpful to understand the further concepts in mathematics very clearly so that the confusions will be fade out. First of all, consider the real line. So the real line means we have to plot the numbers on a line from left to right. So here I have taken for compatibility a horizontal line. Left side we write minus infinity and right side we write plus infinity. Means this line has no end. Okay. It is indefinitely increases in both the ways. Now you see the middle one is we take 0. Right. So the numbers which lie right side of 0 are all positive. The numbers which lie left side of 0 are all negative, right? So for the namesake, I'm just plotting a few numbers, 1, 2, 3, etc. Whereas to the left of 0, we write -1, -2, -3. Of course, there are rational as well as irrational numbers infinitely. Now, you see, the right side one, we denote this right side. This right side part we call R plus. R plus. So this is nothing but positive real numbers. Set of all positive real numbers. Set of positive real numbers. Whereas to the negative side, this one, this side, we write this is R minus. This is set of negative real numbers. Set of negative real numbers are all negative real numbers denoted by R minus. Set of negative real numbers. So we can write here that R equal to, this is R minus union set 0 union R plus. Okay. So now I'm going to explain that how do we define the inequalities and what are the inequalities and what are the algebraic operations on basic inequalities. So here is the definition that inequality. So an inequality is nothing but it is a relation which compares two unequal quantities, right? Two unequal numbers, or you can say a mathematical expressions. A mathematical expressions. So to compare two unequal numbers or mathematical expressions, we will use some relation. Okay. So it is used mostly between two numbers or two expressions, etc. So here It is used most often to compare two numbers on the line by their size. Okay, so here there are two basic strict inequalities. One is the less than, and another one is greater than, right? These are the two strict inequalities. One is the less than here, and another one is greater than here. Well, in contrast to these inequalities, there are other inequalities. Those are the less than or equal to, greater than or equal to. So we have basically four inequalities, simple connectives, right? So this is nothing but less than. So these mathematical operations are useful to compare two quantities, greater than, and this is greater than or equal to. Sometimes whenever we want to compare two quantities, sometimes we don't know whether one quantity is greater than other quantity or they may be equal. So in such cases, we will use this greater than or equal to. So this is greater than or equal to, greater than or equal to. The other one is, this is the final one. This is less than or equal to, less than or equal to. So here less than or equal to implies either less than or equal. Any one of them can happen. Now you see, so how do we use these symbols? Suppose you consider two real numbers, A and B belongs to R. Whenever we say that A and B be two real numbers, we can also write as A comma B belongs to R. This symbol is nothing but belongs to, right? So this is nothing but belongs to. So instead of writing A comma B belongs to R, we can say that A comma B be two real numbers. Right. Now you see, A less than B. A less than B means the quantity A is less than B. How do we say that that quantity A is less than B? When the difference between A and B means you have to take A minus B. So if A minus B is negative, then we write A is less than B. If A minus B is negative, then we write A is less than B. For example, you see 1 minus 2 equal to minus 1. So this is a negative number. So therefore, we can say that 1 is less than 1 is less than. Similarly, A is greater than B. A is greater than B means if the difference of A and B is positive, then we say that A is greater than B. So A minus B must be belongs to R plus. Must be belongs to R plus. So I'll write an example. Here you see that 3 minus 2 equal to plus 1. So this is positive, greater than 0. So we can write that 3 is greater than 2. Right? 3 is larger than 2. Now, what is meant by A is less than or equal to B? A is less than or equal to B means either A is less than B or sometimes A equal to B. Any one can happen, but not both at a time. Only one can happen. Either A is less than B or A equal to B. Similarly, A greater than B means either A is greater than B strictly or A equal to B. For example, we can write that 1 greater than or equal to 1. So here, this implies, in fact, 1 is not greater than 1, but 1 equal to 1. But 1 equal to 1. So any one can happen, right? So here A is, suppose you take a number A. A is greater than or equal to A. Of course, A equal to A, but still we write that A is greater than or equal to A. So if A is not greater than B, if A is not greater than B, then we represent it by A, we write greater than, and you just strike off like this. A is not greater than B. For example, here you see that 1 is not greater than 2. 1 is not greater than 2. Similarly, A is less than B represented by A, you just strike off less than, which means that the meaning of this statement is A is not greater than B. Okay. So here one more example I am giving, that 2 is not less than 0. 2 is not less than 0. Now I will apply algebraic operations on these inequalities. These inequalities are very, very important at the level of school mathematics as well as college mathematics. Here is a very good law of real numbers, that is law of trichotomy. What is this law of trichotomy? Whenever we give two real numbers, there are three possible cases that one real number is greater than the other real number, or one real number is less than the other real number, or they may be equal. So only one can happen among these three possible cases. So for every given number, it is either positive or negative or equal to 0. So every real number is either positive or equal to 0 or negative. So here you see, for a given number, either A is less than 0 or A equal to 0 or A greater than 0. So only one can happen among these three statements. So here 1, it is positive. A number X is given, it is positive. Minus 2, it is negative. Only one can happen. 0, so it is equal to 0. So whenever a real number is given, only one of the following three cases can happen. That is either positive or equal to 0 or negative. So if we give two real numbers, that one is greater than the other, so A greater than B, or they may be equal, or one is less than the other. So for example, I have given minus 2 and 3. Now minus 2 is lesser than 3. So I'll write minus 2 less than 3. Right? For example, I have given 3 and 3. Then how do we write? That 3 equal to 3. Or I can say that 4 and 1. So you can write 4 is greater than 1. So now, how do we use these techniques for further algebraic operations? So here, these are some basic properties of inequalities. Like to say, I have taken some real numbers A, B, C, D. Okay. So what is the first one? Suppose A is greater than B. A is greater than B. And B is greater than C. Okay. So the first one is A is greater than B. And B is greater than C. Then we can say that A is greater than C. We can compare. A is bigger than B. B is bigger than C. So therefore A is bigger than C. Like in a family, suppose there are three children, right? So first children is elder than the second one, right? Second one is elder than the third one. So first one is elder than the third one. So this law is called transitivity. The name of this law is called transitivity. So for example, 2 greater than 1 and 1 greater than 0. So we can write that 2 is greater than 0. Though these simple inequalities seems to be very simple, but they play a very big role in understanding of mathematics, in solving of inequations and equations, etc. So now you see another one. Suppose A greater than B, right? You can add any quantity or subtract any quantity to this inequality. So here a C quantity is added both sides. At the same time, a C quantity is subtracted from both the quantities. So for example, 4 greater than 1. You can subtract some number 2. 4 minus 2 greater than 1 minus 2. This implies here this is 2 greater than minus 1. 2 greater than minus. You can subtract or you can add any quantity. Or for example, x square is greater than 1. So I can add some quantity. X square plus 1 is greater than 1 plus 1. That's equal to 2. Like this. So for an inequality A greater than B, you can add any quantity or you can subtract any quantity. Now, the third one is here C is positive. C is positive and A greater than B and A greater than B. So when you multiply a positive quantity to the inequality A greater than B, the inequality will remain same. The inequality will remain same. The inequality will remain same, which means that whatever the first inequality is there, the same will appear when a positive quantity is multiplied or when a positive quantity is divided. For example, 8 greater than 2 implies 8 into 3 greater than 2 into 3. So here the quantity which we multiplied on both sides is a positive. So the inequality will not be reversed. The same inequality will follow. So this implies that 24 is greater than 6. This is obvious. So similarly, what will happen if a negative quantity is multiplied? So here you see, when a quantity C, negative quantity, is multiplied for A greater than B, the inequality is reversed. Here we have a greater than, this is greater than, but when a negative quantity is multiplied, the inequality is reversed. Or when a negative quantity is divided, then also inequality reversed. Easily you can understand by yourself by taking a simple numbers. See, for example, 8 greater than 3. Okay, this implies Suppose I'm multiplying with minus 1. Minus 1. Here 3 into minus 1. Okay. So now this quantity is nothing but minus 8 and this quantity is nothing but minus 3. Now compare which is more depth. So minus 8 is less than minus 3. Okay. So here greater than we have, but that inequality is reversed. When a negative quantity is multiplied, that inequality is reversed. Or if you divide it by, for example, 8 by minus 3. And here 3 by minus 3. So 3 by minus 3 is nothing but it is a minus 1. And this is minus 8 by 3. So it becomes less than. So greater than becomes less than. So when a negative quantity is multiplied for an inequality, the inequality will be reversed. Will be reversed means greater than becomes less than becomes greater than when a negative quantity is multiplied. Similarly, here you see A is greater than B. Then minus A is less than minus B. Very simple. Because here you see minus 1 is a negative quantity. All right. So A into minus 1, because we are multiplying by negative quantity. So this greater than becomes less than B into minus 1. So this implies minus A is less than minus. When a negative quantity is multiplied, the inequality will be reversed. For example, one example here, suppose minus x less than 0. Minus x less than 0. So now multiply with negative sign. So minus x into minus 1. Okay. So here negative quantity is multiplied. So inequality will be reversed. It becomes greater than that 0 into minus 1. So this implies this minus x into minus 1 becomes x, right? Greater than 0. So these two statements are same. Minus x less than 0 is same as of x greater than 0. Or if we say that minus x less than or equal to 0, this is nothing but you can say x greater than or equal to 0. Both are same. Next, a few more properties of inequalities are left that I am going to discuss now. Here are, suppose you consider two positive quantities, that 0 less than A less than B. So A is lesser than B and both are positive. So if you square on both sides, the inequality will remain same. Here you can observe an example that 0 less than 1 less than 2. After squaring, 1 square is less than 2 square. That is obvious, right? So here I'll give another example that 3 is less than 5. So now you square it, 3 square and 5 square. So 3 square is nothing but 9. 5 square is nothing but 25. Obviously 3 square is less than 5 square. So this is happens when you take a positive quantities, when you take two positive quantities. If you take negative quantities, you see, suppose A is less than B less than 0. A less than B less than 0. Suppose if we take two negative quantities, A less than B less than 0. For example, you see here, minus 6 is less than minus 2. These are the two negative quantities. Suppose if we square them, minus 6 whole square and here minus 2 whole square. Now you see minus 6 whole square is nothing but 36 and minus 2 whole square is nothing but 4. So 36 is greater than 4. So this inequality is reversed when two negative quantities are squared. So a less than b less than 0, that implies a square is greater than b square. Now, a few more left that I will discuss. So here you see that a is less than b, but both are positive quantities. Here you see a and b are both positive quantities and a less than b. C and d are compared, so C less than D and both are positive, then we can multiply these two. We can multiply these two. Okay. And we can divide also. We can divide also. So here you see, for example, 1 less than 2 and 3 less than 4. 1 less than 2, 3 less than 4. So now you multiply that 1 into 3 is less than 2 into 4. So this implies 3 is less than 8. So we can multiply two inequalities provided that they must be positive. Or even we can divide also. Here you see that 4 is less than 6 and 8 is less than 10. Now both are positive. Both are positive. So we can divide that 4 by 8 less than 6 by 10. You can verify it. This is 1 by 2 less than, this is, you can say 3 by 5, nothing but or 0.6. So 0.5 is less than 0.6. So two inequalities can be multiplied provided all the quantities must be positive. All the quantities must be positive. So for example, I'll give one more example. See, this x square is less than x to the power of 4. And 2 is less than 4. So now you see, x square is never negative. X square is never negative. It is greater than or equal to 0. So here both are positive. Assume this is positive. It is not 0. Anyway, x is not 0. So now we can multiply that. It is 2x square is less than 4x to the power of 4. At the same time, here you see a is greater than b, c is greater than d. Now we can add these two inequalities directly, but cannot be subtracted. Here I'll write. Here you see. For example, minus 3 is greater than 2 and minus 4 is greater than 0. Right? Now adding these two. So minus 3, minus 4, obviously greater than 2 plus 0. So this implies minus 7 is greater than 2. It is very clear that two inequalities can be added directly. Now you see the 10th property is A greater than B and C less than D, right? So here you see C is less than D. Now multiply C less than D by -1. When you multiply by -1, then inequality is reversed, that minus C is greater than minus D. Now you can add these two quantities so that you will get like this. A minus C is greater than B minus D. So here these inequalities are given in reverse order. One is greater than, another one is less than. Or you see, here A is greater than B, A is greater than B, and C is greater than D, right? So this implies A is greater than B and you multiply by -1, then you will get minus D or minus C is less than minus D. So this implies A is greater than B and minus D is greater than minus C. Now see, you can add these two directly. We will get that A minus D greater than B minus. So these inequalities are very, very important in solving of inequations, especially in the next video. I will solve a few questions based on these properties.